This is going well. Next up, we have Briq from Forschungszentrum Juelich.
Yeah, hi everyone. So this is joint work by me, Briq, Wang, and Stefan Kesselheim at Juelich Forschungszentrum. We introduce data pruning into diffusion models, generative diffusion models, and investigate their impact on the generation quality. So what motivated our work is that training generative diffusion models is subset that is most beneficial to training. Another challenge is that these data sets are often skewed, which means that certain subgroups are overrepresented while others are underrepresented. And so we ask a natural question: could we prune the data without sacrificing performance? And if so, could we do it in a way that improves fairness? So what is related works focus on this task in discriminative model, which is a much easier task, but in generative diffusion models, the task is much more complex because our aim is to estimate the underlying distribution and reverse a noisy process. And in diffusion models, the task remains unexplored, and existing works rather focus on data attribution or understanding the generalization properties of diffusion models. So our contribution, we introduce several pruning strategies into diffusion models and evaluate their impact. We find that the clustering technique is the one that achieved both diversity and high image quality. And then we evaluate on two data sets. One consists of human celebrity faces, and the other is ImageNet. Surprisingly, we find that diffusion models are very tolerant to pruning. What's even more interesting is that if we enforce pruning in a way that balances the skewed data set, we can mitigate biases and improve the generation of underrepresented subgroups. So just to show you some qualitative results, these are the methods or the pruning strategies that are used and their inverse, and we can see that even the inverse of the method, which means that these are two disjoint subsets, generate similarly looking outputs. That was quite surprising. Here we show that when we prune the dataset in a way that achieves a balanced distribution, the generated images become more diverse in terms of features. For example, we have more diverse skin tones, ages, even hair type and color. And these are some quantitative, just please come to the poster. Thanks.